Hello everyone, I'm Ferdous Nasri from Berlin, Germany, here to present the work from my co-authors and I on creating a platform for global genomic surveillance of emerging diseases that we applied to the monkeypox virus or the Mpox virus. As we all know and learned through the COVID pandemic, genomic surveillance is very important and is crucial in helping contain diseases. This was again emphasized last year as the monkeypox virus or the Mpox virus had a very big outbreak outside of the African continent. It caused over 88,000 cases in 112 countries, and it was soon after also declared as a public health emergency by the WHO. The virus spread with different clades, which were quite different from one another. There was also not one that was declared as a reference genome. This made it even harder to do the genomic surveillance using the tools that we had already used for different other diseases, for example, COVID. We looked at all the different available genomic surveillance tools that were built for Mpox, and we found out that none of them enabled us to use different reference genomes. They also didn't have crucial metadata on their platform. For example, the sequencing protocol that was used to get those sequences. Such metadata is important since different sequencing technologies have different error types that they're prone to. So it's important to take into account when looking at the sequences and mutations. We present a platform for genomic surveillance which is scalable and generalizable. It can hold many data sets, including their metadata, and it has an efficient database structure in the background, so it allows many queries at once. To be more precise, we offer streamlined data gathering and processing platform where the data is also in the end available in a database where it can be queried, and there are visualizations that are made for it and analysis that are available on the graphical user interface, the web server that we offer. We gather the data daily from NCBI. This is done with an automatic script that pulls in all the new monkeypox genomes that are available along with their metadata into our database. We then use a semi-global aligner to align all the sequences to 3 different reference genomes. The aligned sequences are also given to a variant caller, the mutations, and all the data is then saved into our database. This pre-processing and data analytics pipeline is called Mpox Sonar. Then we move on to our web server, which is called Mpox Radar. That's also the link at the bottom that you can see with the QR code. If you go on it, you will get to the web server that we've built, where we offer visualizations about the data. We allow data exploration. We allow our data to be downloaded simply. We allow it to be filtered and so on. I'm going to go through a few tools that we offer in the next slides. All our code is available open source. Our website is also openly accessible for everyone. Now I'm going to show you a few of our tools. The first thing that we wanted to ensure we give our users is an easy data exploration. So we wanted to have a box where they can choose certain filters, and given those filters, they will have a quick visualization of the data that we have in our database so that they can decide what they want to do and maybe come up with other questions. On our exploration page, the users can filter if they want to go through the full data set or only the complete genomes. They can then choose which reference genome they want to look at. And based on their choice of reference genome, the other filters are updated immediately. Then you can see the list of genes. These are also color-coded with their amino acid mutations. Sequencing technologies can be chosen and countries where the sequences were uploaded from, the amount of time that they want to have the data from. There are 2 different visualization methods that we offer. One is to just look at the frequency of the mutations, and another is to look at the trend analysis of those mutations. So if there is an increasing trend or a decreasing trend. And here you go, you get the results. You get a world map of the mutation counts based on the filters that you chose. And you can see the number of sequences from different countries over a certain timeline. You can also move this bar at the bottom to choose a different timeline. And then you can click on the map. And in this case, I clicked on France, given that the ISMB will be in France. And you can look at the number of sequences with the selected variants. Again, each gene has one color and the mutations in that gene are given the same color. This is also followed here, where you can see the mutation development with the frequency of the sequences. All in all, we have over 1,900 sequences on our database. This little dashboard is also available on top of our website, you can also see the number of countries that have submitted their sequences to NCBI and therefore into our database, and the top 3 sequencing countries for Mpox. All of these plots are downloadable. The data that was filtered, given the filters that you've chosen, is also available in a table underneath these plots, and that can also be downloaded as a CSV. We also have a few other tools. We offer a command line tool, for example, which is accessible on a command line or on the web server, where you can give in more complicated queries. This is, I think, most interesting for bioinformaticians in the audience. I'm going to take a second to also mention that for each tool we have a step-by-step guide, which is available on our wiki and linked next to each tool. Thank you so much for sticking with me until now. I'd like to thank our funders and the co-authors on the paper that is already published, as I mentioned before. You can use this QR code or the link at the bottom to look at our web server. All the details are mentioned there, how to get to our paper or the source code. And if you have any questions, please feel free to reach out to me. There's my email and my Twitter handle. Thank you for your attention, and I wish you a great day. Bye-bye.